Good afternoon. This work is titled, Production of Aluminum Oxide Silicon Carbide Composites Sintered by Dilatometry. In recent years, aluminum oxide matrix composite has increased their applications as biomedical area, electronics industry and in the production of precision tools. Aluminum oxide reinforced with whisker fibers or silicon carbide particles significantly improve mechanical properties. One of the most common methods for producing dense ceramic materials, such as aluminum oxide, is the traditional powder processing route. The conventional route involves three basic steps of powder processing: shape compaction and sinterization. The aim of this study is to analyze the effect of SiC reinforcement particles during the sintering process of the aluminum oxide silicon carbide composite. Experimental methodology. A mixture of aluminum oxide with 5% Wt of silicon carbide reinforcement was produced by roto-evaporation, using isopropyl alcohol as a solvent. Then, from the mixture of powders, compacts were manufactured at 440 megapascals by uniaxial pressing. Some samples had a heat treatment at 1200 degrees Celsius for 6 hours in the air before sintering. The sintering was carried out in a vertical dilatometer Lindsay's L75V, up to the temperature of 1500 degrees Celsius for a time of 2h under protective argon atmosphere. The sintering curve can be seen in Figure 6. Results. Through the sintering curves obtained in the dilatometer, the densification of the material during heating was analyzed. Figure 7 shows a comparison curve between the composites with heat treatment and those without pre-sintering. The results reveal that the relative density obtained in sintered compounds only reaches 51% in sample aluminum oxide silicon carbide HT. Because silicon carbide is susceptible to oxidation under the atmosphere of inert gas. As shown in Figure 8, microstructural analysis reveals that sintered composites present a decomposition of silicon carbide reinforcement particles on their surface, leaving macro pores in the material. Observed in the mapping on the aluminum oxide silicon carbide sample in Figure 9. However, when heat treatment is performed at 1200 degrees Celsius and then sintering, the reinforcement particles do not decompose. Instead, they present a decrease in size and rounding of particles attributed to the formation of silicon dioxide on the surface of the silicon carbide reinforcement. As can be seen in the mapping of Figure 10. The experimental results demonstrate that pre-sintered treatment reduce the decomposition of SiC particles on the surface. Thanks for your attention.